Hello friends, hope you are doing well. In today's lecture, I'm gonna talk about the stored charge in diode and diode reverse recovery. Okay, power loss in diode due to stored charge and reverse recovery. And then what is TRR in diode? What is QR in diode? Types of diode and their reverse recovery time. So before I start the lecture, I would request you, if you haven't subscribed my channel, uh, please subscribe it and press the bell icon so that you get notifications of all my upcoming lecture. Please like, share with your friends and family members. Okay. Watch the video till the end so that you get all the lecture notes. Okay, now let's talk about the diode stored charge removal and reverse recovery. Okay, I'm not going much more in detail how diode is functioning, but let's talk about a bit, little bit, how diode is working now. So, if you apply a positive voltage to P region and negative voltage to N region, uh, okay. So what happens is, if you apply positive voltage to P region and negative voltage to N region, there is a minority diffusion of a minority charge carrier, a minority charge carrier from P region to N region and N region to P region. Okay, minority charge carrier diffuses from P region to N region. Due to that, the junction capacitance charges, and because of that, the current start flowing through it. Okay, so if you apply a forward, if you bias diode in a forward bias, okay, so depletion region of PN junction diode reduces. Because of that, current start flowing through it. Okay. Okay, all right. So if you bias a diode in a reverse fashion, okay, how would you bias it? If you apply negative voltage to P terminal of PN junction and positive voltage to N region of PN junction, diode becomes a reverse bias condition. In that particular condition, the depletion region spreads towards P and N region, and the minority carrier charges now pulls out. Okay, so that is how a diode is working. So now let's talk about the stored charge in removal and reverse recovery. Means how you remove the stored charge in junction capacitance, and what is reverse recovery. Okay, let's talk a bit about that. So now, okay, uh, I have uh, drawn a waveform. This is VD, voltage across diode. Okay, over a period of time. This is ID, current across a diode over a period of time. Okay, and this one I have drawn here, minority charge distribution during reverse recovery in diode. Okay, so let's talk about now. uh, okay, uh, during interval uh, during interval t equals to 0 here to t equals to t0 here. Okay, during interval t equals to 0 to t equals to t0, diode is on condition and there is some current flowing through it. Okay, so that is ID. Okay, so diode is, there is some voltage across the diode and some current flowing through it. So voltage across diode is VD on, and some current across the diode is flowing through it is ID on. Right. Okay, means diode is in forward bias condition. Now, uh, during interval t equals to t0 to t equals to t1, okay, t equals to t0 to t equals to t1, you have applied the reverse voltage across the p-n junction and diode is in reverse bias condition. So now diode is in reverse bias condition. So what happens when the diode is in reverse bias condition? Means we start removing minority charges with a negative current, okay, okay. So we start removing negative charges from negative current. So you can see here there is some negative current flowing through the diode, okay. Now what happens during interval of t equals to t1 to t equals to t2, okay, during this interval t equals to t1 to t equals to t2, okay. In this interval diode is off and we removed enough charge, okay, and that point of time voltage across depletion region start decreasing and go negative, okay. At that point of time voltage across depletion region, okay, start decreasing and go negative, okay, during t equals to this point of time, okay. Now let's have a look of minority charge distribution, how it is functioning. When diode is in forward bias, let's say t equals to t0 time, junction capacitance fully charged, okay, there is charge concentration profile over here. The junction minority charge carriers stored in a junction capacitance over a t equals to t0, and during the period t equals to t1, start removing some charges from, you start pulling out some charges from the from junction capacitance, okay, over p and n region. So now here the now here you have less charge stored in the junction capacitance, okay, all right. The thing, one more thing, there is some current slope, okay, okay, this is some slope, current slope, right. The slope determines the diffusion rate and the charge and the current, okay. So at the point of t2 you have reduced some more charges, you have reduced enough charges, you have reduced enough charges, and that point of time voltage across depletion region start decreasing and go negative. So okay, during t2, okay, during this period t3, okay, during this period t3 you removed all stored charge in junction capacitance, right. So let's say here, okay, let's say here earlier your depletion with region width is that much only, okay, that much only. Now once you removed all charge stored in junction capacitance, okay, so your depletion region width increases. Earlier it was that much, now it was that much because you removed all stored charge from your junction capacitance. So you removed all minority carrier charges from your junction capacitance, so the depletion region width increases. Because of that diode is now able to block the reverse voltage, okay, okay, diode is now able to block the reverse voltage, okay, here VDF minus negative voltage, okay, and there is no current flowing through it. So all right, hope you understood that much. Now let's talk about much more. This interval I have already explained during this. Now let's talk about power loss in diode. What is power loss? P equals to V into Y. At time t equals to t0 to t equals to t20, here that is one is conduction loss. At t equals to t0 and t equals to t4 you have a switching losses, right? So now what is a reverse recovery time? Time required to diode to remove all stored charge and block the applied negative voltage. Okay, this one is TR from t equals to 0 to t equals to T4. That much time required diode to remove all its stored charges. That time is called reverse recovery time. Now what is recovered charge? Negative diode current area during reverse recovery. Let's have a lower here, diode stored charge. Okay, so this one is a recovered charge area. Okay, let's example IN4007. The TRR not specified, then fast recovery diode, the example is IN4148, its TRR equals to, now a Schottky diode, let's say SB180, no recovered charge. Okay, so my question is now, why does IN4007 and SB180 does not have a TRR, reverse recovery time? Okay, okay, thank you watching this lecture. Hope you enjoyed the lecture. I wish you a very happy learning. Thank you so much.